So you're using Terraform to deploy infrastructure to the cloud and it all works beautifully, which means you're done, right? Actually, not quite. There's one more very important step that you need to take to make sure that the infrastructure you're about to deploy is following best practices and doesn't have any major security issues. Terraform, in case you don't already know, is an infrastructure as code tool. It's been very popular for years now because even though every cloud platform has its own IAC tooling, Terraform is vendor agnostic, meaning that it doesn't care whether you're using Azure, AWS, or GCP. You just write some code and then Terraform handles that deployment on your platform of choice. That makes it especially useful if you're a multi-cloud shop or if you're trying to prevent vendor lock-in. But if you're watching this video right now, you probably already know what Terraform is, so let's get to what it is that you're here for. But if you're not familiar with Terraform yet, drop me a comment below if you'd like for me to create a video on Terraform. Okay, so if you're using Terraform, you need to be running some sort of IAC and policy as code scan. If you come from a development background, IAC scanning is essentially SAST scanning that analyzes your static code for common issues that you might otherwise miss, because we're all human, unless you're an AI, and policy as code scanning, which checks for violations in your organization's policies. But instead of just talking about it, let's look at an actual demo. For this demo, we're going to use an open source tool called Checkov by Bridgecrew. Checkov offers IAC and policy as code scanning and will be a perfect tool for this demo. By the way, they are not sponsoring this video and there are other options out there. This is just the one that I chose for this video. And if you'd like to follow along, you can grab the code from this repo either by copy pasting the main.tf file or by downloading it locally and then extracting the archive. And by the way, real quick, while Terraform deploys real infrastructure that can cost you money, we're not actually going to deploy anything in this video, so following along is not going to cost you anything at all, just so you're aware. All right, so let's install both Checkov and Terraform to get started. Because I'm on a Mac OS system, I can use Homebrew for both of these installations. If you're not on Mac or if you want to use an alternative method, check out the README that's included in the repo for additional steps. You can then make sure that it installed successfully. And next, make sure that you navigate to the directory where you have your main.tf file and we'll initialize Terraform with this command. You should be seeing an output that looks like this, and it might take a few seconds. Now, normally to be able to execute this Terraform file to actually deploy resources, we would need additional configuration, but we have everything that we need to run Checkov, which is the point of this video. So let's now go ahead and actually run Checkov. Checkov can scan entire directories or it can scan individual files. In this case, we only have one file that we care about right now, so we can scan it like this. After a little bit of time, your results should look like this. And we can see that we have quite a few issues that are being reported. So let's take a look at one of the issues to see how we can fix it. The most obvious issue in this Terraform file is that we are hard-coding AWS credentials. You should never ever hard-code credentials, regardless of whether we're talking about application code, Terraform code, or really just about anything else. But I'm not going to go into that tangent in this video. Instead, I'll reserve that for another video. With that said, there are a few things that I'd like to point out here. We have a unique and helpful identifier that starts with CKV_AWS and then a number. This is a number that we can use to look up this exact issue. Although as you can see, Checkov provides an explanation in the results. We need to ensure that no hard-coded AWS access key and secret key exists in the provider. There's also a guide with a link to Palo Alto Network's documentation that again provides more information if you don't know how to fix the issue or what the issue is even about. So let's go ahead and fix this problem by removing the hard-coded credentials, which in our case simply just requires that we delete these two lines. And instead, Terraform will use the system's default AWS credentials, which is a much better alternative. After removing those lines, if we rerun Checkov, we'll see that it no longer has an issue with hard-coded credentials, but we still have multiple other problems. So let's quickly go through and fix some of those problems. One of the other issues is that we are allowing traffic to ports 80 and 22, which are ports for HTTP and SSH respectively. And because we have a range of 0 to 65,535 for the ports for both ingress and egress, that includes the ports of 80 and 22, which is why Checkov isn't happy. Let's go ahead and fix that. I'll update the ingress rule to have from port equals 22 and to port equals 22. And then I'll add an IP address in the CIDR blocks. And this is just an example IP address for demo purposes, but otherwise, obviously, you'd want to use your real IP or your office's real IP. Then we can rerun Checkov after we save this file. and it will continue to complain about other issues, but you shouldn't be seeing the issues that we just fixed. As an example, another complaint that it has is that we need to ensure every security group rule has a description. Instead of showing you how to solve this issue and the rest of the issues, if you're following along, go ahead and solve the rest of the failed checks on your own. And then in a second, I'll show you my solution and I'll rerun Checkov for a clean bill of health. If you get stuck at any point, remember to check the documentation link for more information. Alright, so I've got this fixed version here that you can check in the repository that I linked to earlier to compare with what you've fixed. Let's rerun the scan using this fixed version or your fixed version, and you should not be seeing any more issues. One great part about a tool like this is we didn't have to configure anything at all. All of these checks came pre-configured with the tool. However, you can also create your own custom policies, and this is really where the policy as code comes into play. What we've seen so far is checking for issues against best practices. These are practices defined by the developers of this tool as to what should be considered the best practices for the resources that you're deploying and in the platform that you're deploying to. But your organization will also have its own policies that it will want to enforce. As an example, an organization may want to restrict the types of EC2 instances being used, or they may want to dictate which VPC CIDR blocks should be used in order to maintain standards. That doesn't necessarily protect against security issues in this case, but it's the company's policy, and so we want to set up policy as code scanning to automatically enforce those policies in this project. Let's take a look at how we would do that. And there are a few ways of creating custom policies with Checkov. One is using Python, which is useful for checking for the status of configuration attributes, which is what we've done to this point. And the second is using YAML, which can also do what I just said, in addition to checking the connection state between different types of resources, so it's even more advanced. For this demonstration, we'll be using Python because we're going to keep it simple. Let's create a new directory if you don't already have it by having downloaded the repo. You can name this just about anything you want because we can pass in that name as an option later, but I just named mine custom policies. Then in that directory, we need to set up a file named init.py. In that file, we need to add the following code, which you can go ahead and copy paste from the repo or just download the file. From there, we can add our own custom checks by creating new files like the ones that you see in this directory. This basic check will ensure that VPCs are using a CIDR block range within a specific range. In this particular example, we're looking to make sure that it starts with 10.0 and then whatever else after that doesn't really matter. So let's go ahead and grab the vpc.tf file from the repository if you haven't already, and let's take a look at the CIDR block in that file. We can see that the VPC CIDR block range is configured as 10.123.0.0/16, which should fail this check. And let's see if it does by running the command. As we can see, Checkov failed this custom policy check just like it was supposed to. We've successfully defined our very first custom policy as code. As another example, let's write another policy that checks to make sure that we're not using t2.micro EC2 instances. Your organization might want to do this to control cost, especially if it's restricting larger instance types, or maybe it wants you to use a different class of instances like T3 instances instead of T2 instances for performance reasons. Whatever the reason, let's see how we can do that. Again, you could create a completely different file and then paste the following code in there. We can then run this policy against our main.tf file, although mine isn't fixed yet, and I'm using a separate fixed main.tf file, so I'll use that instead just to minimize the noise, but you could be using whatever you'd like. You could use your main.tf file if you'd like. This new policy that we just created will fail the check because we're trying to create a t2.micro, which is a violation of our policy. If we were to change that value to t3.micro, then the check would pass, as we can see here. That's it. You've now run infrastructure as code scans, and you've learned how to create your own custom policies to also run policy as code scans. And by the way, you could have a tool like this running as part of your CI/CD pipeline or straight from your IDE, like in VS Code, which is what I'm using right now. You can search for it and add it, which means you get recommendations as you write your code and pre-commit. Where you implement it depends on what you and your team want, but you have the options. Otherwise, that's it for this video. Your next step is to implement what you just learned so you can make sure that your Terraform code is good to go. I hope that you enjoyed this video and tutorial, and if you did, please do me a huge favor, like the video, subscribe to the channel, and send this video to someone else that you know, maybe a colleague who needs to learn about IAC and policy as code. Sharing with colleagues and on social media is one of the best ways to help the channel grow, and I really appreciate you taking the time. Thank you, and I'll see you next time.